Hello guys, I'm Alukosha Enoch. Welcome to our math tutorial on sequence. In this tutorial, I'll be taking a look at linear, quadratic, and cubic sequence. So let's take a look at the question. For each of the following sequence, work out the next three terms. Work out the nth term. Use the nth term rule to work out the 20th term. Now guys, for any given sequence, the first thing you have to do is to determine the nature of the sequence. For example, if you look at 5, 13, 21, 29, 37, if you take 13 minus 5, 21 minus 13, 29 minus 21, and 37 minus 29, you see that it has a common difference, and that's a constant. The first difference is a constant, and that is 8. Okay, so let's just go ahead with the question now. So you label 1, 2, that is I want to label the sequence 3, 4, 5. I'm going to use table method for the remaining two questions. I supposed to use table method also for this linear question, but it's going to be like a waste of time because I have a better method to work with. Okay, so let me just go with this. So 5, that is the sequence now. So 5 is the first term. 13, that is the second term. 21 is the third term. 29 is the fourth term, and 37 is the fifth term. Guys, and because of the next two questions, I'm going to use table method. So let me just put this in a table so that at least you will be used to this. So even though I'm not going to use table method to complete this because I want to be I don't want to waste much time with linear sequence. Okay, linear sequence is quite simple. So what I did is just to I have my sequence in a table, then I label. Okay, so let me continue now. So the first term is actually 5, 13, 20. Okay, so what I'm going to do now is to take the difference. So T2 minus T1, T3 minus T2, T4 minus T3, and T5 minus T4, and that gives plus 8. So you see it increases by 8. So I'm not going to continue with table method here. Through with my question. So so I have 8. The difference is 8, and 8 is the first difference. So let me target the one. Okay, let me just put something down here too. Okay, if I'm to use table method, table method is such that if I have a first term, if the first if I have first difference, then I'll use this concept or formula. If it's second difference, then I use this concept of formula, and last difference I use this concept of formula. So what are the concepts? So D1. If I have first difference, if first difference is a common difference, then you have the difference. I put in brackets now. The difference times n. So that will give me my formula. If I have a second common difference, that is, if second difference is a constant, then I have half of the common difference, half of it. You just divide the difference into 2, and then just add n squared behind it. But if I have if the third difference is a common difference, that is a constant, then you're going to do 1 over 6, take 1 over 6, 1/6 of the difference, and add n raised to power 3 behind it. So I'm not going to repeat this formula for the subsequent for B and C because I'm going to wipe the board. So but just take this take note of this, guys. So I can just put a constant here. Let's just say 1 times common difference. So it's common difference. So the common difference here is 8. So you have 8n. So that's the implication. So then since this is a linear sequence now, you now ask yourself, what can you do to this 8, that is the coefficient of n, to get the first term, which is 5. So what can you do to 8 to get 5? That is plus 3. So we can confirm if this formula actually sorry don't mind me. What can you do to 8 to get 5? Is that plus 3 or minus 3? Can be playful sometimes. So minus 3. So what can you do to 8 to get 5? 8 minus 3 will give me 5. So the formula is or better still, the nth term is 8 minus 3. Let's confirm that. When n is 1, that is 8 times 1 minus 3, that is 5. When n is 2, 8 times 2, that is 16. 16 minus 3, that is 13. When n is 3, 8 times 3, that's 24. 24 minus 3, that's 21. That's all. So just confirm the remaining one. So we have to work out the next 3 terms. So the next 3 terms, so this is T5. So T6 now. So when n is 6, let me just go ahead. So the sixth term now, T6. So I'm to work out next 3 terms, mean that T6, T7. Why am I writing T7 first, guy? So T6, T7, and T8. That'll be the next 3 terms. Okay, so T6 will be 8 into 6 minus 3. Then I'll get the answer. So T7 will be 8 into 7 because n is 7 minus 3. Then I'll get the answer. Then T8 will be 8 into 8 minus 3. So can I just bring up my calculator now? Okay. Okay, so let's just do this. So I have 8 times 6, 8 times 6 minus, let me just press equals to first, minus 3. So so that's 45, meaning I'm going to have 45 here. So 6 will give me 45. Then this the 7th term and the 8th term now. Guys, because of our time, will I be just waste my time with that calculator? I don't know why it's. Can you come back here, guys? Okay, so the next one, 8 times 7 minus 3, I think it should work. Yeah, so that's 53. And finally, 8 times 8 minus 3, and that's 61. So that's so the next 3 steps. So we are cool with that. So the next question is use the n term rule to work out the 28th term. So the 28th term is T20. So T20, that will be 8 into 20 minus 3. 8 into 20 minus 3. So let's see what that is. So 8 times 20 minus 3. 8 times 20 minus 3. And that is 157. Okay, so that is the 20th term. So I'm through with the first question. Let's go with the next question, the second question. Okay, but we need to import this again. Okay, insert image. I'll just place it on it, and I can make reference to this first question again if need be. Okay, so I can't wipe the board like that. Okay, just bring this thing here. Can I make it bigger now? Yeah. Okay, I think it's okay like this. Okay, I think I just need to cover the whole page so that I don't run into trouble. Okay, just bring it here. I'm just to okay, I can bring this one down. I need to cover everything. Okay, and that will also confuse you guys. Okay, okay, I think everything is okay like this. Okay, so through with the first question, let's just go ahead with the second question now. Um, you already know the rules. Okay, I'll just go ahead with the question. So to label this one first, let me just put down the sequence. I have 6, 14, 28, 48, 74. Okay, then I label 1, 2, 3, 4, 5. Okay, let me just put it in table. Okay. Don't mind me, my table is somehow. Why am I like this guy? Ah, don't mind me. Let's do that, guys. I'm sorry about that. Okay, so that's cool one. Okay, it's in table already. I just need to do this. Okay, so let's take the first difference. So I'm going to call that D1. Okay, D1. Let's see if the first difference will be a constant. 14. At this time, I'm not sure I'm going to use that virtual calculator. I'll just use calculator with me here so that I'll be a little bit faster. So 14 minus 6, that's 8. Then 28 minus 14, 28 minus 14, that is 14. 48 minus this is 20, and 74 minus 48, 74 minus 48, that is 26. So as you can see, the first difference is not a constant. D1 is not a constant. So the implication is that this is not a linear sequence. This is not a linear sequence. So so let's take the difference once again. 14 minus 8 now. 14 minus 8. 14, guys, 14 minus 8. That is 6. 20 minus 14, that is 6. And 26 minus 20, that is 6. So you can see that the second difference is a constant. So since the second difference is a constant, then the implication is that this sequence is a quadratic sequence. This is quadratic sequence. The first one we saw was a linear sequence. Okay, because we have first difference here. So now for quadratic sequence, let me now draw this table properly now. Let me just do that. Okay, hope I should be able to manage this board well. Okay, I think everything is okay like this. Okay, let me just go with my, I wouldn't have taken much time doing this, but not a bad deal. Okay, so what I'm going to do is just I just need this table. I can make it, can enlarge it, or I will just know how to work with it with time. Okay, so don't forget that the up here we have the label 1, 2, 3, 4, and 5, and here I have the sequence. So let me call this okay, T. Let's just start this T. So the first term is 6. This is label. Let's target n. When n is 1, n is 2, n is 3, and these are the terms T1. So this is 14, and this is 28, and this is 48, and this is 74. So I've been able to confirm that the common difference is 6, and that is second difference. So, and I said it before now that when you have second difference, then you take half of the difference. Then you just place n square behind it. So half of 6 is 3. So I'm going to, so I have 3, then n square. So I'm going to generate 3n squared now. So when I generate 3n squared, then I'll take away t minus 3n squared, then I generate a new term. Okay, so let's generate 3n squared now. So when n is 1 squared, that is 1 times 3, that is 3. When n is 2 squared, that is 4 times 3, that is 12. When n is 3, that is 9 squared. 9 squared times 3, that is 27. Then when n is 4, that is 16. Okay, 16 times 3. 16 times 3, that is 16 times 3, that is 48. Is that interesting? 48. So when n is 5, that is 5 squared will be 25. 25 times 3, that is 75. So don't forget this is I generated this so let me just start our formula now. So our formula now, I've gotten the first part of the formula, which is 3n squared. 3n squared. So just keep that. Okay, so now and I've been able to generate 3n squared. What I'm now going to do is you just do 3n squared minus t. So 3n squared minus t. So mean that the number below minus the number above. So 3 minus, so that will give us a new term. So let's call this one t0. So this is a new term now. Let me target t1, a new term now. So I'm going to treat new term like a new question. So 6 minus 3, that is 3. 14 minus 12, that is 2. 28 minus 27, that is 1. 48 minus 48, that is 0. What's going on here? This is 25 times 3, because 5 is n is 5, so 5 squared is 25. So 25 times 3, I just I must be sleeping there. Okay, so this is actually 75. Sorry about that. So 75 minus 74. I've got that one, right? Okay, actually to take away up minus down or down minus up minus down. So t naught, that is up 1 minus down 1. So 6 minus 3, 14 minus this one. So this is minus 1. Okay, so now this is a new sequence now, because I'm from here I have the first part of the formula. Okay, that is 3n squared. Then I have to take the difference of t naught and 3n squared, and that's this result. So the resulting sequence now is 3, comma. Should I work here? Why am I so I need to manage my board very well. Let me just work here. So the new sequence now is 3. I don't want to put it in the table because it's a new sequence. 2, 1, 0, then minus 1. So this new sequence, you now treat it like as though you have a new question, given a new question like this. So now let's take a look at this. What type of sequence is this? Is it a linear? Is it quadratic? Is it a cubic sequence? So how do we determine that? By taking the difference. So 2 minus 3, that is minus 1. 1 minus 2, that is minus 1. And this is also minus 1. And this is minus 1 minus 0 is also minus 1. And you can see that when I take the difference first time, it's a constant. So d1 is a constant, meaning that it's a linear sequence. And how do I work with linear sequence? I'll just put that number there. So minus 1n. Then I will now ask myself, what can I do to this constant here to get the first term of the original sequence? So what can I do to minus 1 to get 3? That is plus 4. If I add plus 4 to minus 1, I'm going to get 3. So the remaining part of the sequence will now be, so this is a linear, because a linear sequence, that's what I did first time. The first question is a linear sequence, and this is the method I use. So, and this is the remaining part of the term, of the nth term. So so minus n, I don't need to write minus 1n, so that's just minus n plus 4. Let's confirm if our formula is correct. So when n is 1, I have 1 square. Okay, so 3 times 1 is 3. 3 minus 1, that is 2. 2 plus 4, that is 6. So we generate the first term. Let's see if the second term will give us 14. When n is 2, that is 2 square. 2 square is 4. 4 times 3, that is 12. Okay, 12 minus 2, that is 10, then plus 4, that is 14. Guys, you can confirm the remaining one. The formula is correct. Okay, so that this is the formula. Okay, so we are through with that. So then work out the nth term. We've been able to work out the nth term. We can work out the next 3 terms. So next 3 terms means that next 3 terms after this now. So this is still 1, 2, 3, 4, 5. So that is when n is 6, 7, and 8. So I'm going to find T6, T7, and T8. So guys, I will not really waste much time doing this. I'll just plug everything into calculator and get my answer from here. So I'll just plug everything into calculator like that. So I have 3, open a bracket, 6, I close it, square, minus 6 plus 4. So that's when n is 6. So I have 106. So this is 106. You can confirm, guys. Then when it's 7, I will just edit my calculator here. So just put 7 in the bracket. So 3 into 7 square. 3 into 7 square minus 7. Then plus 4. Minus 7 plus 4. And that is 144. So T7 is 144. And finally, when T is 8. So let me edit again. So when n is 8, so that will be 3 into 8. 3 into 8 minus 8. 3 into 8 square minus 8. Then plus 4. And that is 188. So that's the next 3 terms. So that's all. Finally, we have to use the nth term rule to find the 20th term. So I can go ahead and work with this one. So T20 now. So T20 will give me 3 into 20 square to 20 square. Okay, it's okay. Into 20 square minus 20. I don't know why I'm taking my time to write this, guys, but it's just not bad because of time. I need to be very fast. Okay, minus plus 4. So let me just plug that into calculator too. So let me just edit this. So I'll just replace it with 20. So 3 into 20 square minus 20 plus 4. Okay, so and that gives me 1184. So 1184. Okay, guys, thank God. I think at this point, let me just wipe the board so that I can go for the last question. Okay, so let me insert the question back. Okay, guys, hope you enjoy that method. That's a very simple one, guys. You don't need to start writing algebraic equation, guys. So I call this a table rule, okay, or table method, or whatever. So up to you guys. Table method, table rule, whatever. But I just find it cool and easy for me. Okay, so okay, finally, till this question now, I have 2, 9, 28. So don't forget, I don't know whether we should just go for a table, but don't let me draw the table first. Let me just go ahead with the question. 2, 9, 28. Oh, see my handwriting, guys. 65, 125. Don't forget that the first thing you have to label your sequence. Okay, you just label the first term, the second term. So why am I writing like this? The third term, T3, the fourth. And guys, I don't need to do that. When I want to draw the table, I'm going to complete that. Okay, so let's just go ahead and determine the nature of the sequence first. Is it a linear sequence? Is it a quadratic sequence? Or is it a cubic sequence? Don't forget, okay? So 9 minus 2. So 9 minus 2 is 7. I don't know why I'm taking my calculator for this. 9 minus 2 is 7. Okay, so I'm just lazy. 28 minus 9. That is 19. Wow, this is definitely not a linear sequence because then the first difference is not a constant. Then 65 minus 28. 65 minus 28. So that is 40. Wow, they say, see the gap, guys. Okay, 125 minus 65 now. 125 minus 65, that is 60. So definitely this is not a linear sequence because the first difference is not a constant. So let's take the second difference. So let me just put there d1 is not a constant, so I'll just write d1, then I will cancel it. It's not a constant. Then let's take d2. 19 minus 7. Okay, so what is 19 minus 7? That is 12. 12. Okay, 40 minus 19. Okay, I think that should be 21. I don't know why I'm taking calculator for that. 21. And this is 20. Well, so the second difference is not also a constant. So since the second difference is not a constant, therefore this is not a quadratic sequence. It's not a quadratic sequence. So let's take it finally now. 21 minus 12. 21 minus 12 is 9. Okay, and 20 minus 21, is this 20? Yeah, 19 7. 19 minus this 40 minus 19. 40 minus 19 is 21. 2 9 26 is 5 126. Oh, don't mind me, why am I working like this? 126. Even though 2 9 28 65 126. Why did I put 125? God. Okay, 126. Even despite, let me see what's going on there. So 126. Okay, so this is 7 19 65 um 7 28 minus 9. Oh, why are you wasting my time, guy? 28 28 minus 9 is 19. Then 65 minus 28, that is 37. Oh, don't mind me, I'm sorry about that. Let me just undo that. I don't know why am I sleeping, guys? Oh my, this is a big deal, guys. And this is not going to undo. Oh my, let me just continue from here, guys. Oh, sorry about that. 28 minus 19. This is not funny, guys. 28. What? 28 minus 9. That is 19. Then 65 minus 28. I don't know. I just like 37. Am I sleeping, guy? Oh, this is 37. I don't forget that this is 126. I don't know why I just put 125 here. So 126. So I can go ahead and do oh sure. Okay, 126 minus 65 now. 126 minus 65. That is 61. So the second difference still not the same. So hope I didn't make any. This is actually the first difference. So the first difference is not the same because this is the question 2 9 28 65 and this, so and this first difference not a constant. So let's take second difference now. Don't know, I'm just too. Oh god. Okay, 19 minus 7 now. 19 minus 7. I'm trying to be very fast and doesn't make sense. I'm making mistake, guys. 97 minus 19, 18, and 61 minus 37. 61 minus 37, and that's 24. So the second difference is not also a constant. So D2 is not a constant, so it's not a quadratic sequence, so I'll cancel that. So finally, 18 minus 12 is 6, and 24 minus 18 is 6. So the third difference is a constant. So I'm going to give that a tick. So meaning that it's a cubic sequence. So now don't forget that for cubic sequence, what do? We do 1 over 6 of the common difference, then times n raised to power 3. So from here, you can see that the first part of the formula will be, because this is 6, this D is 6 now. So that's n3. So the first part of the formula is n3. So at this point, how do I manage the board now? Okay, let me just go ahead and draw my table. I don't know why I use this side, guys. I should have used this side. So let me just do it here. 1 over 6. So that I can use the table there. This is going to be a, it's not funny, guys. So I'm going to generate n3 there. So I can start with my table now. I don't know why. Why am I like this? I want to undo that. It's going to undo. Oh, God. I can't erase this thing. Okay, can you just take? I need that space there. I need this space there. Okay, I need that space there. Can you help me? Okay, whatever. So let me just bring out my table here. That's why I don't like this electronic board, because I import the question. So cool one. I should have left it down. Don't mind me. Okay, so this is cool. I don't know if I'm going to use, need more. Okay, let's just take it like that. Okay, so guys, I think that's cool. Hope you understand what I did there. You want me to rewrite everything now, do everything now, guys? It's like this Aloko guy is not well organized. Yeah, sometimes I can be very guys. So don't forget what I did there is 1 over 6 into D. Our common difference is 6. So 6 divided by 6. So this is 1 over 6 into 6. Then times n3. Okay, so that is n3. So that's why the first part of our formula is n3. So I can start my formula here. I'm going to complete it. So Tn will be n3 here. So before I start the table, so I can write 1 when n is 1. This is n. Okay, the real question is T. Let's call it T naught. Okay, let's just target T naught. So 1, 2, 3, 4. Okay, 5. So and the question 2, 9, 28, 65, and 126. Okay, so then so when we use this method, we are able to the third difference is 6, and we use this formula, we're able to generate so n3. So n3 is the first part of the formula. So let's generate n3 now. That is not n3, guys. Why am I like this? N is n cube, n is power 3. So when n is 1, that is 1 raised power 3, that's 1. 2 raised power 3, that is 8. And 3 raised power 3, that is 27. Guys, I think I'm not good in maths, right? So what is 4 raised to power 3, guys? So that's 64. 5 raised to power 3 is 125. Am I correct, guys? Just confirm for me. Okay, so now based on table method, all you just do is that up take away down, up take away down, up take away down, up take away down, up take away down. Okay, so 2 take away 1. So we are going to generate a new sequence now. So let me just put the new sequence here, guys. Let me just put it here. New sequence. Let me target T1. Okay, I think I can work here. I don't know. That will be quite rough. Okay, so let's generate this sequence now. 2 minus 1, that is 1. So T1, new sequence. So 9 minus 8. Oh, I'm just fortunate, guys. 122. Whoa, this is not funny. I'm looking at. I think I'm going to generate something like a quadratic sequence. I'll now apply quadratic method to generate a new linear. But fortunately enough, I just have a constant here, guys. Game over. So I'm going to make a video on a more difficult one. Okay, so that's a good one. I think I like this question. So because when I generate new sequence now, coincidentally everything just gave me a constant 1 1 1 1. So this is a constant. Do you understand? So you just add plus one. If it has to be something like maybe 1 2 3 4 5, that would be a linear sequence. They use a linear sequence method. And if I give you something like you generate this question 2, then you use a quadratic sequence. Just add that formula behind it, guys. I think the game is almost over. So this formula, let's just confirm if it is correct. When is n is 1, so 1 raised by 3 is 1, 1 plus 1 is 2, correct? Okay, when n is 2, 2 raised by 3 is 8, 8 plus 1 is 9, correct? Guys, let me just do one more. When n is 3, 27 plus 1, that's 28, guys. So I don't have any problem there again. I almost undo that. Okay, so now let's go ahead with the next three terms. So that will be T6, that will be T6, T7 and T8. T67 and T8. So I think that's going to be an easy one too. Okay, T6 now. When that's 6 raised by 3 plus 1. So 6 raised to the power of 3 plus 1. And that's give me 217. 217. Okay, so T7 will be 7 raised by 3 plus 1. So 7 raised to the power of 3. So just change this one to 7. And that is 344. 344. Guys, don't mind my handwriting. It's pretty cool, right? Then 8. So when n is 8, then I have 513. 513. So T8 is 513. Guys, am I correct? 513. Yeah, 513. So then T20. Let me just do T20 here. That's 20th term. So when n is 20, T20. So that will be 20 raised by 3 plus 1. 20 raised to the power of 3 plus 1. Guys, I think that's not funny, right? So let me just do that. Yeah, it's okay. 20 raised to the power of 3. 20, guys. Whoa, that is 800. 80,001. Guys, with this, we've come to the end of this tutorial. So I hope you enjoy this method, guys. Just try and go ahead and you can see more worksheet. Just go to the my uh page or on test, that you can access some questions. You can also download question online from test. Just type quadratic sequence on Google. There's any test, quadratic sequence test, or maybe cubic sequence test. It is like that. So guys, do subscribe to my channel, and do have a great day ahead. Bye bye, guys. Bye, guys. See my calculator up and down. Yeah, guys. Be blameless and innocent children of God, appearing as light in the world. Bye, guys. Love you guys. Bye, bye, guys. Do and subscribe to my channel and like, guys.